If we had computers that knew everything, using the data that they gathered without any help from us, we would be able to track and count everything, which would in turn lead to reduction of waste, loss, and cost. Hi guys, this is Neil from Edureka and welcome to this interesting Edureka live session on IoT explained with IoT careers and market trends. Now, let's go to the core, or let's go to the start, or talk about the idea which brought the concept of IoT into the picture. It was a statement made by Kevin Aston, which spoke about how we need to empower the computers with their own means of gathering information so that they could actually hear, smell, and feel the world for themselves in all of its random glory. This statement, made by Kevin Aston in 1999, was one that actually brought the concept of IoT into the global picture as well. Now, when I talk about IoT, let's try to address the most fundamental question, which is what is IoT? Now, IoT is a concept or a technology or even a domain which actually aims to create just one thing. It helps us achieve a world where all the devices and appliances are connected to each other through a network and collaborate with each other in order to achieve or complete various complex tasks, which definitely requires a high level of intelligence. Now, if I had to if I had to summarize this, it basically comes down to the statement, which is Internet of Things is an interaction between the physical and the digital world using the various sensors and actuators as well. Now, when I need to understand IoT, I need to first get an idea of how things actually work in the Internet of Things domain. So let's try to get a glimpse of how the workflow works in the IoT domain. Now, always the core fundamentals or the key concept here are sensors. Sensors are present all around us. They gather information for us. But once they have gathered information, what happens to them? They start emitting this information to a storage data. Now, the storage center may be present on cloud. It could be a database. Depending on the various architectures that's out there, you can use it anywhere as well. Now, once I have this information, then I begin to process this information. Before I go on to get insights from this information, there is one very important thing that I need to take care. That is, I also need to create triggers for the issues as well as the challenges which have encountered with these sensors as well. If so and so action is faced, then what to do? Now, let's take a real world example to help you understand this. Let's try to understand an example of a car. A smart car is something that all the organizations or all the businesses today want to create out there. Self-driven car is just one of the examples out there. Let's say tomorrow there's a failure with respect to any of the component of the car. In such cases, you need to avert all the corresponding responsible people. And if I know it in the first case itself, then it makes it very easy for me to prevent this in happening from future as well. Once I have this information, or once I've created this actionable item and I've faced all, or I have ensured that there are no more challenges ahead, then I can be sure that the information that I gather is always going to be reliable as well as useful as such. Now, once this data is present, you take it on and you processing it using the various machine learning as well as artificial intelligence techniques that are out there. This could be deep learning, that could be natural language processing, anything that the user requires. What this information is going to give us is not just an insight on what information is gathered, but also help us improve our overall system as such, because this feedback in itself is going to be fed back into the sensors. Now, this completely becomes a workflow, or this is a cycle that happens with respect to it. Now, when this comes on, or when this keeps happening, your system starts to learn, it starts to provide with better information and starts to customize to the user's requirements as well. To give you another example of the entire ecosystem, let's take a case of how we travel from home to office. Let's say on a daily basis, I switch on the AC once I reach home. If my machine knows that I'm leaving my office at so and so time, it can already customize, or it can already turn on the AC, and it'll be cool by the time I get home. Really nice implementation, right? This is a way how you customize, or this is a mechanism through which you bring personalization into the ecosystem as such. Now, talking about the next important concept, which is the overall architecture associated with IoT. When I come down to the architecture, there are mainly three fundamental layers associated with the overall architecture, or overall the IoT's domain as such. The first layer is the perception layer. Now, when I talk about the perception layer, it becomes a layer wherein you gather information using the various sensors and actuators. This gathers all the information around it and uses it as per user's requirement. Once I have this, it comes to the responsibility of the network layer to transport or to move this information from the sensors to an application which will process and give insights from this information. The application layer does the same. It understands the information that it comes to us, and it also helps you understand what is needed, what is happening, and what can be done as well. If you want to enhance this, I can also add two more layers to this, wherein I add a new layer which is the transport layer. When I have the transport layer, this mainly deals with how the information is going to be processed from the sensor to the processing layer, or how it has to be moved from here to there. Now, this can be done using 3G sensors, it can be done using LANs, Bluetooth, RFID, or NFC as well. There are various other ways as well, and these have various shortcomings or various standards also incorporated to create a standard measure. An example to this could be an IPv6 format wherein you use shorter forms for identifying these devices. IPv4 in itself has a limit, and this is why IPv6 shortcode is also used. Now, if you want more information on the IoT architecture, you can check out our video on IoT architecture as well. The next segment of this is one of the most interesting thing and what people want to know, which is cloud computing in Internet of Things. Now, if you go back to our previous slide, we talked about the complete workflow of how IoT works around. Now, in cloud computing system, I can have any part of this present apart from the sensor on a cloud-based environment system. I can have my processing taking place on the cloud computing system. I can also have the visualization and application taking place on the cloud computing system. A variation to this is something known as fog computing, which actually gives us faster insight with respect to that same. Now, cloud computing, although is much more efficient, which requires only low power sensors as because this processing takes place on the cloud, fog computing is something that can be used on the real world in order to ensure the real-time challenges are met. To give you another example of this, let's say we have an ambulance which is moving from a traffic signal. Now, if I identify that a ambulance is moving from the first traffic signal, although I can clear it, but the same process has to be done for the next traffic signal while I'm working on a cloud computing system. This is where fog computing actually comes down. Rather than sending the information all the way up to the cloud computing system, I'll send the information to a fog computing machine wherein it'll actually process this on the gateway level itself and provide information or provide a path for the ambulance to move ahead without any further challenges as such. Next, let's talk about the various taxonomies associated with IoT. These are the key keywords which make the architecture or which makes the entire ecosystem necessary and useful as such. The first is the perception. Now, again, we've talked about the perception layer as well. Perception here basically means to collect the data using various sensors that's around us. Now, once the data is gathered, then I'm going to begin processing. Now, the processing or the pre-processing here can also help us to gather or take valid information. You need to understand that most sensors stream real-time data, and this is a huge amount of data that comes around. If I can ensure that only valid information is taken ahead, then it makes it quite useful for me to get insight as such. Then comes the communication. Now, again, in communication layer, there are various protocols and standards that you use in order to achieve very seamless system that's out there. Based on the various components and architecture that you use, each communication protocol has its advantage and its disadvantage as well. Now, we have middleware which actually acts as an abstraction which hides the necessary hardware details. An application does not directly need to interact with the sensor. It just needs to pass on or process information or create a request as well. And this is where middleware really comes into the users, or it comes to the advantage of the overall system as well. Now, when we talked about the 5 layer architecture, there was one layer that we missed out, which is the business layer. Now, one thing that's really important in the IoT domain is to understand how the overall environment really works out. So for a business or for an organization, it's essential that you understand how each of your smart devices works. So if I have, let's say, I create a water if I create a smart water filter, or if I create a smart AC that's out there, my business layer will actually give me an overall insight of how each one of these devices are working, and how the challenges or information is gathered from them as well. The user's experience or user's information also will help me improve my overall business as such. Finally, we have the application. Now, application is one of the collection, or this is what you usually most use for your interface, or you use to process your information. Now, applications can do various usage with respect to it. This is what usually most people look at, and this is what we interact with. It's the other segments that really are what brings out the interest in IoT domain as well. Now, coming down to the demo for this session. Now, I'd like to take this demo session in two parts. Firstly, we would talk about how a smart sensing system or a smart environment can help us improve the overall experience for a user. But as this is a limited timed session, what I would do is that I would give you a first side glimpse, or a first half of the a glimpse of the first half of the overall machine, where we'll gather this information and we'll process on this as such. Now, how the overall machine works is you have an application which is present, which gathers the information which is connected to the IoT hub client, which is on the end on the cloud machine. Now, one thing that you can keep in mind is this is mostly kept keeping the Azure services in mind, so you may find some of the key concepts present here. Then when you come into the configuration segment, you need to understand whether the weather data is coming from Sensat is good, or whether it's false as such. You need to identify which is true, which is false, and that goes into the telemetry section. Once it's present here, then it moves on to the cloud, wherein the complete processing, the gathering all takes place, and you go on to create various dashboards and visualize on the information that you have. Now, let me switch on to my VNC. So what I have done is that I have my IoT device present here, and I'm going to switch on to the VNC, which will actually give you a glimpse on what the Sensat is showing. So this is just connected over the network. Now, to keep the various in order to keep the various references, or so here, as you can see, I have defined red, red, red. So as you can see, there are three variables that will be mostly be using: red, green, and blue. Now what it is being used for, let me just give you a glimpse into the same. Okay, so I've defined temperature using red. Okay, pressure becomes green, humidity is blue, and for quitting I've used gray, which is basically 000, or white in this case. Now I'm going to display these four characters on my Sensat on four different regions as such. And then what I'm going to do is that if I select on each of these options, then it is going to be giving me the temperature, the pressure, and the humidity as well. Based on each option I select, I would get a corresponding output as such. Now, let me show you the Sensat here. A quick confirmation that you guys can see my screen would be helpful. Can you guys see the Raspberry Pi? Okay, so I'm going to just execute the code. Okay, so here what you can see is there are four options. Now it may not be perfectly clear for you, so let me bring it down. So what you can notice here is there's a temperature, there's a pressure, and there's a humidity. Based on each option I choose, a corresponding output is going to be defined. So let's say if I choose on temperature, I click on press, the temperature is going to be displayed. So as you can see, the temperature is being displayed. If I press again, it's going to restart, and it's going to show me the same temperature as well. Once it has showed me the temperature, it brings me back to my menu where I can check the humidity, or if I want, I can check the pressure as well. Now once I have done testing this, then I can always quit this using the quit option. Now this is just a sample use case, so this is just an example of how Raspberry Pi can be used for each of the users as well. Now, this is just one single example that you may see or you may come across. In a real world or in your programs, you need to constantly gather this data. So the constant gathering of data needs to be pushed through various APIs, which we've already discussed in some of our previous program or previous videos as well. And if you are more interested into the various programs that you can write in IoT, you can definitely check out our playlist as well. Now, if I come back and I talk about one of the other aspects or the other important part of today's session, which is the various applications that IoT can use. Now, these are just some of the examples where IoT is being used. You need to understand that IoT today is restricted only by the idea of its user. There is no such domain wherein you cannot use IoT. Each domain has a useful insight or a useful application to IoT as well. Be it from the energy consumption segment, be it an architecture segment, be it agriculture, be it home automation, smart environment, health and fitness. If you feel today there is no IoT implementation in a domain, then I can assure you it's only because no one really has imagined a solution to using IoT in that domain as such. Now, what is IoT or why is it gaining so much interest? Let's talk about the trends with respect to IoT. Now, what you can see here is just the Google interest of how much IoT has gained over the past few years. IoT is considered one of the biggest dark horses of technologies in the last 2 years after blockchain. This is one domain that's really gathering a lot of attention, and even if you actually look at how much it is gaining attention, you can see with respect to the numbers present here. Now, as you can see, Forbes predicts that the global market size of IoT by 2020 is going to be close to 457 billion, and even the potential annual contribution by 2020 is around 300 billion as such. This is a huge domain or huge investment that's happening into one single technology. And when you talk about the careers with respect to these domains and what can be done here, connected cars, smart devices which help process your health data on real time, even congestion, traffic congestion which we daily face can completely be smoothened while using IoT. Now, even if you see which domain today is gaining a lot of attention for IoT professionals, it's healthcare, telecommunication, transport, retail, and manufacturing. Now, what you need to understand is the misconception that most people have is that IoT is mostly for electric engineers or people who work on the electronic segment as such. That is one of the key challenges why today most people refuse to move into this domain or are not aware of this. Each domain that you come from, be it a telecom, be it from an IT, be it from any other domain that you come from, you have a scope in the IoT space. Now, what does an IoT developer really get? As per Indeed, it's about 91,000 per annum, and this is just the average. We've seen various people get different job roles also. And when I talk about job roles, let me give you an insight on this. There are In today's world, there are mainly 4 different job roles which IoT professionals are offered to. But what you need to understand here is that these job roles are something that came up with respect to the interest of IoT. If you look back 2 or 3 years, these roles were not even present out there as such. So definitely this is one space that's gaining a lot of attention, and you should definitely consider a domain change if you are looking to upscale yourself as well. Now, when I talk about an IoT engineer, they mainly design and orchestrate the complete IoT solutions associated. They design how sensors to be connected, what has to be implemented, how does it have to work. This is mostly something that anyone would really love to enjoy as part of their work. And when we talk about an engineer, they build the entire environment on which the IoT devices communicate with each other. They come up with solutions for each of the challenge faced by the users as well. And when you come to consultants, they are on a higher level where they come with solutions on how you can help or how you can implement IoT in your existing machine or system as well. And finally, IoT developers themselves develop various applications which integrate or process the information that is gathered by these machines. Now, when I have or what I want to bring out to your focus here is that today Edureka definitely offers an IoT training. This is something that we also have understood with respect to the market demand, the market trends, and we have also introduced into the market so that a lot of people can catch up with respect to the demand and go beyond as well. When I talk about Edureka's training on IoT, this course mainly consists of 10 various modules that you will be covering over a span of 5 weeks. And the last two modules of our course actually gives you a complete hands-on on various real-time projects as well. So these are projects that are used in the real-time industry as, and definitely you'll be learning how to work on them, how to create them, and also how to implement them as well. Now, the first module is something that gives you an insight on IoT, and then we'll talk about how to use Raspberry Pi and the various sensors associated. Now, although our course is mostly focused on Raspberry Pi, but this does not restrict a user to understand the various devices that are used in the IoT domain space as well. And this insightful information would be definitely shared by Edureka. Now, when I come to the third module, this helps you understand how you can create various solutions using Raspberry Pi and Sensat. You will be working on various projects as part of this course, part of this module as well. That will give you a good idea on how to use these devices as such. When I come to the fourth module, this talks about the various communication protocols that is used, how you can pass your information from the devices, which kind of protocol to be used when, and what works out as well. And then you have the most interesting segment, which is IoT and cloud computing. So how an IoT based solution can be implemented using cloud computing, and what its advantages and disadvantages. Now, for our learning, we'll mostly be using Azure as the cloud computing platform for our learning, and you'll get a complete insight. Now, this is mainly because of how many features Azure has today released with respect to the IoT domain as well. So if you ask me which is the cloud computing space which is gaining a leap or gaining a lead in the cloud computing space, or sorry, within the IoT space, it is Azure. So definitely we'll mostly be focusing on how you can implement an Azure based IoT project, and how you can create a remote monitoring system and alert system as part of the seventh module as such. Now, in our seventh module, what demo we've seen today, we'll understand how to deploy a full scale implementation of the same, and we'll talk about another interesting concept, which is edge computing, as part of our eighth module. As I said, the ninth and 10th module talk about various industry based projects as such. Now, let me just give you a glimpse on how Edureka offers training. So you can check out the Edureka's IoT training page. My team will be sharing the link with you, and if you want to understand more about the demands and trends, so whatever information you saw about the trends of IoT that as part of today's session was gathered from thousands of our learners as well. So we have a report that shares you or gives you complete insight to this demand and industry. That's what they need, and IoT is also in the top here. So definitely, if you are interested, you can give us our details and you can avail the skill report as such. Now, if you want to know more, or if you want to explore more in the IoT domain space, then you can check out our YouTube videos. We have a huge playlist which gives you various projects associated to IoT as such. Now, with this, I come to a conclusion of today's session. Hope you had a great learning experience. Thank you.